this is Connie Belden, and in this video we're going to take a look at preference ranking, profitability index, and simple rate of return. Okay, let's talk about profitability index. That's very easy to calculate. You just take the present value of the cash inflows. So for project A here, it's $88,600, and divide it by the investment required. And I'm going to put it in as a negative, since it's written in there's a negative, so that way it will make the profitability index a positive. So that's 1.48. Now we'll talk more about what that means, but let's go ahead and calculate the others. So 260,600 divided by 190,000 is 1.37. 68,600 divided by 110,000 is 1.53. And 355,100 divided by 965,000 is 0.37. So what we could do is use this profitability index to rank which ones we would want to do and which ones we may not want to do. Maybe we can only do one of them. If that's the case, we'd want to do the one with the highest profitability index, which is C. Okay, the next highest profitability index is A at 1.48. The next highest is B at 1.37. And the last is D with 0.37. So that's how we want to rank those. Okay, next we're going to take a look at simple rate of return. Simple rate of return is different from net present value. Net present value and IRR use those tables, and so therefore they are considering the time value of money. Simple rate of return is not, so we won't be using the tables for this. Okay, so assume the new machine costs $54,000. Yearly cost to operate is $14,000 for the old machine. Yearly cost to operate the new machine is $6,000 because it's more efficient. Salvage value of the old machine, if we trade it in, is $20,000. And the useful life of the new machine is 10 years. The salvage value of the new machine is 0. Okay, we are looking at buying a new machine to replace the old machine. What is the annual depreciation associated with the new machine? And we will be using the straight line method, which will be cost of $54,000 minus salvage, which in this case is salvage of the new machine is 0, divided by its life in years, which it says it would be a 10-year life. Okay, when you calculate that out, you get 5,400 is the depreciation expense per year. Okay, let's go down to question 2. What is the annual incremental net operating income provided by the new machine? Okay, well, let's start with the operating cost of the old machine is given to you at $14,000. The operating cost of the new machine is $6,000. So if we take the difference, okay, we get, before we do that, we do have to take out the annual depreciation on the new machine as well, which we calculated in part 1 was $5,400. Now we can look at the annual incremental net operating income by taking the operating expenses of the old, okay, subtract out the operating expenses of the new, and the additional depreciation of the new, and we actually have an additional $2,600. So we would actually save $2,600 by buying the new machine over the old based on our situation in part 2. Okay, in part 3, it says, what is the initial investment for calculating the machine's simple rate of return? Okay, well, we would take the cost of the new machine, which if you look up here is given at $54,000, less any salvage value from the old machine. Now, the new machine had no salvage, but the old machine said had $20,000 in salvage. So that means it's going to cost you 54. Think of it as you're buying a car for 54, but you get 20,000 trade-in on your old. So therefore, your actual initial investment is $34,000. Okay, so now what is a simple rate of return for the new machine to one decimal place? Okay, so we can get that by taking the annual incremental net operating income and dividing it by its initial investment. So I will take my answer from part 2, 2,600, and dividing it by the initial investment, which is 34,000, because remember, you're getting 20,000 out of the old machine. When you divide that out, you will get a simple rate of return of 7.6%. Thank you very much.